There you go. You want to do some statistics? You can do a t-test and a z-test for statistics. All right, does anybody have anything in particular before I start going through problems and taking problems out that you would like me to go through? Nobody, huh? Well, I'm going to look at problem number 2, and we're going to approach number 2 two different ways. In problem number 2, we have f of x is equal to 1 over 9x minus 7 to the 5th. Hopefully, I have the right worksheet. Speak up if that's not the number 2 that is on your worksheet. All right, what we have here is we have two different opportunities. We could do this two different ways. Once again, there's more than one way to skin the proverbial cat. We can look at this as a quotient rule, which is the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. That's the first way we can have it dealing with this. So if we look at this as a quotient rule, we have the derivative of the top, which is just the derivative of 1 times the bottom. Well, Ozzy, what is the derivative of 1? What's 0. 0. So we have 0 times the bottom, 9x minus 5, or 9x minus 7 to the 5th power, minus the top, which is 1, times the derivative of the bottom. Well, if I take the derivative of the bottom, we have to use our chain rule. So if we use our chain rule, Dylan, what do we have here using our chain rule?
5 9x minus 7 parentheses 4 to the 4th.
Yeah.
Times 9.
Times the value of 9. And then this is over our bottom squared. So if we take a look, we have this 0 times this function, or times 9x minus 7 to the 5th. This all goes to 0. Here we have a negative 1 times 5 times times 9, which gives us negative 45 times 9x minus 7 to the 4th power over, once again, we have a power to a power. Carmela, when we have the power to a power, what do we do with our exponents?
Multiply.
Multiply, so we have to the 10th power. But then we take a look, we have 4 9x minus 7's on top. We have 10 of them on the bottom. How many can we cancel out, Liam?
4.
4 of them. So we're going to be reduced to 6. So we have negative 45 over 9x minus 5 to the 6th power. Once again, if we take a look at this a different way, we can come down to the same solution. Whoopsie. We have 1 over 9x minus 7 to the 5th power. Using our properties of exponents, we could take this 9x minus 7 to the 5th power and bring it up top. And put what exponent with that? What would be the exponent that we could put that allows us to bring the 9x minus 7 to the 5th power and just put it up top? What exponent could we have or put to that? Brandon?
-5.
-5. So now if we take a look, maybe, there we are, at the derivative. What I want you to do is I want you to apply your quotient rule, or not quotient rule, but chain rule to this. Take your -5 out front, drop your exponent by 1. Multiply it by the derivative of what's inside. Nathan, what do you have?
I have 1 times -5 times 9x minus 7 to the -6th power times 9.
Okay, so now the only thing that has a negative exponent is the 9x minus 7. We can drop that to the bottom, but the 5 and the -9 stay on top. So these stay on top. This gets dropped to the bottom. So we're left with 5 times 9, which is -45, over 9x minus 7 to the 6th power. Once again, either way is a correct way of dealing with it. If we take a look at number 7 on the back, we have cosine to the 4th of 9x cubed. Once again, when our trig function is taken to an exponent, when a trig function is taken to the exponent, rewrite this and bring the exponent outside. So we have the cosine of 9x cubed to the 4th power. Okay, and once again, if you've not done this one, please do it. The only time that you can get, the only way of getting better at these is working through the problems. Okay, so we're going to use our chain rule. So our outside exponent goes first, and recopy everything inside. So we have 4 cosine 9x cubed, and we drop our exponent by 1, which gives us 3. And then we chain that with, now we start working ourselves inside. We go inside, the first thing we come across is the trig function, which is the cosine, so take the derivative of cosine, and recopy the 9x cubed. Baylor, what's the derivative of cosine?
Negative sine.
Negative sine, so we have negative sine of 9x cubed. And then we go inside of that and take the derivative of the 9x cubed, which is what, Evan?
27x squared.
27x squared. Now we start combining all these things that are being multiplied together. So we see we have a 4 here, and a 27 here, and a negative here. So we can combine 4 and 27, which gives us 108. And we throw the negative with that. So we have negative 108 x squared. We could take our exponent of 3 and move it back into the trig function. So we have cosine cubed of 9x cubed. And then we have the the sine of 9x cubed. So there would be our derivative. Once again, a common mistake is people start to take the derivatives of multiple things at one time. The 27x squared, what sometimes happens, what I see is we'll be okay with this, then we'll take the derivative of cosine to get us negative sine, and then they'll take the derivative of the 9x cubed to give us 27x squared, and not have it in there, have the 27x squared here, which is incorrect. If we take a look at problem 28, or no, I'm sorry, number 8, my bad. We have the cube root of e to the x. We can't deal with radicals, cannot deal with radicals and derivatives. So we had to put it into an exponential form to be able to deal with radicals and derivatives. So we have e to the x, and we have the cube root of that. The cube root of this. What exponent do we have to put with the cube root? What exponent do we put with the cube root? Adam.
1/3.
1/3. And once again, as Carmelo has shared with us a few times, we have a power to a power. And if we have a power to a power, we can multiply these powers together. So we can either write this as 1/3 x or e to the x over 3 power. Either way is fine. So if we take a look at our derivative, we have an e function. And when we take a derivative of our e functions, Dylan, how do we start out the derivatives of our e function?
E to the 1/3 x.
E to the 1/3 x. We just recopy. We just recopy. And now we're going to change it to the derivative of our exponent. So we have the derivative of 1/3 x. Liam, what's the derivative of 1/3 x?
1/3 x is a -1.
Nah, what do we do? We have an exponent of 1 here. What do we do to apply it?
Be 0. Or
1/3, I mean.
Just 1/3. There we go. We take our exponent 1 and multiply it by 1/3, which gives us 1/3. And we drop our exponent by 1, which is x to the 0th power. X to the 0th power is just the value of 1. So we just have 1/3 there. So our solution is 1/3 e to the 1/3 x, or putting this back into a radical form, putting the process back into reverse, this value right here, the e to the 1/3 x, takes us back into the cube root of e to the x. So we have 1/3 cube root of e to the x power. Once again, solutions need to be put back into radical form. Need to be put in radical form and simplified radical form. Or you could write e to the cube root of e to the x over 3. That would be fine. This is more than acceptable. Or if you have the cube root of e to the x divided by 3, that would be fine too. Whatever works for you, I'd accept either or. Just need to make sure you get it back into radical form. Any other ones you would like me to go through?
The last one?
The last one, the square root of x squared plus 9x minus 7. It is the Miami Dolphins of the 1971-72 Miami Dolphins. It's a no name, no number problem. By the way, that was the last undefeated team throughout the entire NFL season. But they only had to play 12 games plus a couple playoff games, so they didn't have to play 20 games. A little bit tougher now. Once again, in this form, you need to write it exponentially. Hopefully we know that's to the 1/2 power. So bring your exponent out front. Drop your exponent by 1. And then go inside and take the derivative of what you have inside. So we have 1/2 x squared plus 9x minus 7 to the negative 1/2 power. Once again, a common mistake here, very common mistake, is people will do the 1/2 and then take it to the negative 1/2 power, but then they'll throw the derivative in here. They'll take the derivative of x squared plus 9x minus 7 and get that on the inside, which is incorrect. We had to chain that with respect to multiplication. We have x squared plus 9x minus 7, which hopefully by now we can say is 2x plus 9. Anything with a negative exponent is going to go to the bottom. If I ever have a fraction, the 2 will also drop to the bottom. So this will drop down to the bottom, give me 2. I have a negative exponent here. So this is going to get the square root of x squared plus 9x minus 7. And this has no negative exponent to it, so this is going to go on top. 2x plus 9. So we have 2x plus 9 over 2 square root of x squared plus 9x minus 7. Any other questions? All right then. Once again, as I told you, we're not going to use the whole time today. The second half here, which takes us to 10:30, I think. Yeah, 10:30. So you have 45 minutes here. What I would suggest you do is, this is not the time to sit there and say, I'm not going to worry about it anymore. You have time that's allotted for you to work through problems. To go to the second worksheet, and what I'm going to do is we're going to do number 9 together, because the trig functions tend to be the ones that give us a little bit more difficulty. So if you pull out your second worksheet in your packet, just take a look at number 9, which is y equals secant of 5x squared. So if we take a look at the derivative, we take the derivative of y with respect to x, dy dx. Once again, this is y prime. If this is a function f prime at x, this is all ways of writing derivatives. The first thing we come to is we have to take the derivative of secant. So now we have to flip through our notes and try to remember what's the derivative of secant. The derivative of the secant of x. Ozzy, did you find it?
1 over the cosine?
Yeah, it's 1 over the cosine. We can write it that, but we also took a look at finding ways of doing a derivative. If I just have the trig function secant of x, what's the derivative of secant of x? Yes, I get it's 1 over cosine. I could rewrite it that, and then I could utilize my quotient rule to be able to do that. But we can also just go back to the idea of secant. What's the derivative of secant?
Secant of x times the tangent of x?
Secant of x times the tangent of x. So if we take a look, now this would be the secant of 5x squared times the tangent of 5x squared. It's not the secant, and I know how people memorize and think about these, and they'll sit and say, well, the derivative of secant is secant tangent, and they'll just write the secant tangent of 5x squared. No, this is the secant of 5x squared times the tangent of 5x squared. And then we go inside, take the derivative of 5x squared, which I'm hoping that this is something that becomes second nature to us now. It would be 10x using our exponent rule. So our derivative is going to be 10x secant of 5x squared times the tangent of 5x squared. Once again, not a very difficult thing, but we have to just remember what's the derivative of secant. We'll take a look at one more here. We'll take a look at number 8. We have y is equal to the cosine of x times the cotangent of x. We have two functions being multiplied together. If we have two functions being multiplied together, we must use our, what do we have to use if I have two functions being multiplied together, Nathan?
The product rule.
The product rule. So we have the derivative of the first times the second plus the first times the derivative of the second. So go ahead and take your derivative of the first term and multiply it by the second. Derivative of cosine is what, Carmela?
Negative sine of x.
Negative sine of x times the second, which is cotangent of x, plus the first cosine of x times. Now we have to go back and find the cotangent. What's the derivative of cotangent?
I have the negative cosecant squared x.
Yep, negative cosecant squared of x. Now what you have to really be careful of, this is still multiplication here. This is not cosine of x minus cosecant of x. This is cosine of x times the negative cosecant of x. So if I take a look, we have negative sine x times cotangent of x minus, I could take this negative and throw it out front, cosine of x times the cosecant squared of x. Now, this is fine to leave it this way. In some books, if this is a problem in the book, this may not be the answer that's provided in the back of the book. Because what they'll do is they'll start utilizing trigonometric relationships. This is fine, but remembering fond memories, cotangent is cosine of x over sine of x. Here we have minus cosine of x over 1 times 1 over sine squared of x. Well, what happens nicely here is the sine of x's, they go bye-bye. So we have negative cosine of x. Over here, we have cosine of x times 1 over sine of x times 1 over sine of x. And what they'll look to do is they'll combine these together as cosine of x over sine of x. So this will take us back to a cotangent of x times cosecant of x. Because 1 over sine of x is still your cosecant. It's just what books will do for you. I don't know. They want you to relive your fond memories of all your trigonometric things. To me, this solution here is acceptable. That is acceptable. If you want to take it all the way down and continue to utilize trigonometric ideas because you have such a fond memory and liking to all your trig identities, go for it. I would count either one as the correct solution. You could even, leave it as a cotangent of x here, and factor out a cotangent of x out of both of these. There's so much simplification. It depends on what everybody sees. All right, that takes us to about 10 o'clock. Once again, the rest of these I will leave for you to work on, but this will be the last day we deal with chain rules. On Wednesday when we come in, we'll work with what's called implicit differentiation. Once again, it tends to be that next level of differentiation, but it's all practical applications and techniques of taking derivatives. And as I told you before, the whole first semester of calculus, once you get past limits, you had to define what a limit is, which gives definitions of derivatives. It just continues to build. And the majority of this chapter, or majority of this class, is based on derivatives. Our next this chapter and also the next chapter, all deal with the idea of derivatives and applications of derivatives. So the hope is sometime at the end of January, beginning of February, we're done with derivatives. We're going at a good pace, which is good. We'll get through them a little bit quicker than I've had in the past. Other questions that you have? Once again, the last half hour here is for you to be able to just work on these and get done what you need to get done. I would discipline yourself to make sure you get these done right now, rather than go back and lay back down for another half hour, Liam. Or go get some Pop-Tarts out of the cupboard and sit there and chew on some Pop-Tarts. Go get your Pop-Tarts out. Go get your Pop-Tarts out of your bowl of cereal. Get your bowl of Fruit Loops out. Sit there and work on some calc problems. That would be my suggestion to you. Other than that, I have nothing else for you unless you have something for me. I will see you on Wednesday, same time, same place, same station. Some of you I'll see in physics class here in, about another hour or so. And I don't know. When's physics? Physics is
10:40.
10:40. I will see you in about 40 minutes. So do what you need to be able to do. All right. See y'all. Bye.